I'm going to do very little today. I'm going to introduce some people. We're going to have a few presentations and then a panel discussion. I think we learned in our past session there's quite a lot to talk about in this particular problem area, if you like. This session, and we hope we're going to get a lot of interaction from you. There are a couple of different routes you can interact with us during the next hour. A problem in the title of the European Open Science Cloud, of course. If it was the European Fair Science Cloud, data can be fair without being open, if it doesn't need to be open. However, not all data can be open. So we've got a set of solutions that some of us are working on in the EOS context, which should hopefully, by the end of the projects at least, allow the European Open Science Cloud to deal with types of data where there's a slider on the word open. How open can this be to fulfill its legal responsibilities? As I say, I'm not going to tell you about this. We've got a couple of speakers today. So we'll start with a couple of slides outlining a couple of projects that Horizon Europe have funded for us to bring trusted research environments, if you like, to allow sensitive data reuse in the EOS context. We'll spend about 20 minutes on the slides at the beginning. You may have questions. I hope you have questions. We won't break for questions in between the talks so that we can keep the panel discussion more interactive. But if you do have questions on your way through, please use the Slido. We've got it working, so you can put your questions in there. I'll leave it up for another 10 seconds while you suddenly remember that you have to get your phone out and connect. And then we'll go into the next session. And the next session will be chaired by me. I will literally do nothing except go and sit over here. But we've got three excellent speakers today. We have Hedi Leena from CSC, the IT Center for Science in Helsinki, Finland. She's going to talk about the EOSC Trust project. I'm coordinator of the EOSC Trust project, and so have an interest there, of course. We have Antonio Scarmetta, who you may have seen if you were in the previous session as well. He's going to tell us a little bit more about the Titan project. He's a professor at the University of Murcia. He's got a long history working in cybersecurity and Internet of Things. And Ville Tenhunen from the EGI Foundation. He's the data solutions architect at the EGI Foundation. And he's going to be telling us about the Siesta project. So these three projects were all funded under the Horizon Europe project, under the EOSC umbrella, to allow us to deal with sensitive data in the EOS context. So, as promised, I'm going to say no more and hand over to Hedi.
Okay, thank you, Peter, and good afternoon, or is it evening to everyone? Maybe I'll just say moikka and be done with that. So I'll really briefly take you through what the EOSC Trust project is about. It's a little bit tall, this thingy. So EOSC Trust stands for European Network of Trusted Research Environments. This first slide is about the motivation for the project, but I don't think this audience needs a whole lot of convincing about that. We have some challenges trying to be as open as possible and as closed as necessary in the plenary. Earlier today, we heard both from the commissioner and the deputy director general that EOSC is supposed to be trustworthy and secure environment for research. And it feels like the secure term is popping up more and more. But at the same time, we want to hold on to the value of openness. So the mission of EOSC Trust is to create a European network of trusted research environments for sensitive data. That's in the title. And also drive European interoperability by joint development of a common blueprint for federated data access and analysis. So we are not creating a federation. necessarily. That's maybe a little bit up for debate. But yeah, federation is might be at least at some point along this path, not for this project, but maybe something we're moving towards in the TRE landscape sooner or later. 4 main objectives for the project. So again, this is, I guess, the third time already that I'm mentioning the network of trusted research environments. But the thing that I could stress here is the linkage to EOSC and EuroHPC. So we're not existing in a vacuum. Then the second objective, recognizing, not necessarily creating or inventing standards and a framework, but recognizing the relevant framework and standards, both in terms of legal, operational, and technical for trusted research environments. Then the third objective is creating awareness among national funders and governments so that they recognize and are aware of this network of TREs and the capabilities, both the existing capabilities and the potential and upcoming capabilities. And the last objective, and this is especially relevant here in the EOSC Symposium, is to position this network of trusted research environments in the context of European Open Science Cloud and the Common European Data Spaces. So the project partners can be roughly put into 2 groups. The drivers, which represent the use cases, and the providers. And here you see the drivers. We have 4 drivers. 2 represent health data-ish, and 2 other types of use cases. 1 social sciences, and 1 especially the public-private collaboration. And I think this is a good point to remind that this project and TREs are not only about health data. They need to serve other use cases, and especially in the EOS context, because we have to kind of find the not to duplicate the efforts or done in the EHDS context, but find a kind of definition for TREs in the EOSC context. Here's a slide about the partners who are drivers, moving right along. So the providers are the ones who are providing the trusted research environments. Either they are already in production or being developed. So there are 16 provider organizations in this project. We did recently an inventory of these trusted research environments, and we came up with 19 TREs that these organizations are representing currently. And I should mention that I am the co-lead for the Trusted Research Environments Provider Forum work package in this project. So that's my role more specifically, and why I'm here presenting these slides today. Yeah, and many of these providers are national actors serving national communities with national funding. And here's a list of the providers. I'm not going to spend more time on that, but you can find it in the slides when they are made available. So one main output of this project will be the reference architecture for the TREs. And it will address also the researcher identities, data authorization, workflow processing, and things and such. My background is in social sciences, so please don't ask me anything about RO crates, but I'm sure there are people in the room who can answer questions about that in my stead. Architectural principles that we are working based on the 5 SAFEs framework and the EOSC interoperability framework are kind of the foundation for this work. And here's a picture of the different, like the way the project is organized. And here I would especially point out the way the architecture is there in the middle, the drivers feeding input about requirements for TREs, and the providers feeding information about the capabilities, and these 3 work packages kind of form the core of the project and form this kind of feedback loop. So there are iterations of the architecture that are then kind of validated by the providers and drivers throughout the project. And this is my last slide. So just to summarize, so the ambition of this project is to take Europe and EOSC beyond the state of the art in European collaboration, connectivity, fair data workflows, and also European HPC. Thank you, and looking forward to the panel and your questions.
Thank you very much, Hedi. And I think next we have Antonio Scarmetta from the University of Murcia.
I was checking it.
Unless I've swapped your order.
Yeah, it's mine. Okay. Again, thanks for the invitation, and I think I will not try to repeat basically what I did previously, just to go to the concrete aspect that we are working at already in Titan. So Titan, as already mentioned, is for trusted environment for confidential computing and secure data sharing. As already mentioned, our main focus is on the definition of certain components, enablers, that basically will support the capability of providing these confidential computing nodes, and also how they should be integrated on an architecture or environment where they facilitate the secure data sharing and the possibility of doing privacy-preserving mechanisms in that sense. Okay, I will not come again with this. That is the main objectives, I think, but this one that I didn't mention previously, I think is relevant from the point of view of what are the technical aspects that we are covering in our project, in that sense. So basically, as already said, our vision or our objective at the end, if you like, is to create this end-to-end secure data sharing and collaborative platform in that sense that support the possibility of the distributed access control, as we mentioned previously, and the discussion that we have. The main idea is that to provide this access control through the integration with the self-sovereign identity mechanism in that sense that will facilitate the definition of certain control rules about how to access the data, how to integrate privacy-preserving, I was at mechanism over the solution, how to provide what we call domain segmentation. So as we just mentioned previously, to create ecosystem that can define a certain governance model so that we can manage basically in that environment certain rules about how to share, how to protect the data, how to provide traceability about the interaction that already have been provided in some sense, and also, and finally, how to provide usable and scalable data anonymization techniques that should be integrated as part of the sharing process, as you will see later. Part of an enabler that is the connector that will be one of the pieces that we are trying to evolve from the existing definition. So in order to get that, we have 3 main areas of work in that sense. One of them is the provision of what we call confidential data processing capabilities in that sense, and data processing through the integration, as already said, about the use of GPUs, confidential machine learning, secure environment where the different data can be processed. They provide scalable data anonymization techniques that can be offered in some sense on the data sharing, using different techniques. Here we put some of them that we want to work. Data privacy-preserving anonymization, or zero knowledge proof, for example, as one of the significant one in that sense. And finally, how to integrate all of this over a distributed access control and transaction, or traceability mechanisms that can be managed this decentralized solution, as we just mentioned to one of the questions that was bring previously in the panel in that sense. And for that, we are going to use, DLT technologies, or we propose the use of DLT technologies. One example could be the blockchain, but can be more general, and the definition of the integration in them about the access control and management solution in that sense. Okay. As already mentioned, this at the end bring us the idea to support this secure environment that I already mentioned, linked to what we previously presented. So how to provide how to integrate in all the process this access control solution, how to provide the privacy preserving specifically in the context of application of machine learning techniques also, so that we can offer enclaves that are able to provide the possibility of processing the data using certain kind of AI and machine learning algorithms in a secure and trustable way in that sense, and how all of this should be also integrated, as I already said, in a process to discover, announce, and find the different nodes that will be able to offer this capability, either if you are a provider or either you are a consumer. So in some sense that we can be able to integrate and provide an orchestration model around it. In order to do that, we have an initial architecture. I had a high-level architecture where we already have identified building blocks. For example, what we mentioned previously, we are thinking and defining what we call this governance ecosystem in order to support all the functionality through this identity and trust model based on self-sovereign identity, the creation of a catalog in that sense where we can register, as I said, or consumer or producer, and where we can look and make a searchable of what they are offering or what they want to in order to facilitate this orchestration, and obviously to provide the mechanism to check the compliance, the traceability, the monitoring of how the processing has been carried out in that process. Also, we have what we call the infrastructure layer, if you like, that with the idea to how this should be supported by our DLT in that sense, how we can also provide the possibility to have a kind of a possibility of deploy dynamically certain components based on certain requirements in that sense, so that we can offer like a marketplace of services, if you like, so that we can use and do the secure enrollment of that components on the different nodes. And then the basic piece is what we have as a central plate, that is basically this data ecosystem, where we are, as I said, taking the idea of the connector coming from the data space, where we are extended so that every node that is part, either consumer, either processor, either producer, will have this kind of functionality that will allow to facilitate all the data sharing and the processing capability that we are trying to offer in that sense. Based on this, one of the pieces, as you can see here, is the idea that inside the different nodes, we will have different subsystems as part of our architecture, where we will have this is the basic connector that we can have in the data space. This data space can be integrated with the confidential processing that can be implemented later on, you can see here, on a TE or a secure element or secure enclave, or either in FPGA scenarios. And then we will have this extension that we mentioned here, that will be the privacy and security manager connector that will be in charge of providing the wallet for the connection to the governance model and to the trust model. And then obviously we will have a component in charge of the usage control for the provision of the PDP and a PEP that will be in charge of implementing all the protection mechanisms over the data, the application of certain operation over the data, so that we can do anonymization if it's necessary, or do some kind of pre-processing previous to the data sharing, depending on the decision. No? And here you can see, I mean, some instance of how this PDP, PDP, and elements will be. At the end, and this I conclude, at the end what we want is to have, as I already said, a kind of orchestration process. Here you can see some of the technology that we are now integrating in our case, so that at the end you will be able to orchestrate a processing where basically through either on the DevSecOps operation plus some kind of tool like Terraform, etc., you should be able to indicate what kind of processing you want to do, over which node, etc. And at the end, the entities that are or being producer or being consumer of that data will have this extended connector that will be in charge of managing and processing the operation of the data sharing, taking into account the privacy preserving, the security aspect, or the confidential computing capabilities, executing them on a certain kind of trust environment that we can consider in our environment, being a TE, being a secure element, or whatever it is in that sense. Okay, so basically with that I conclude. Our idea is basically to see how this architecture that we are mentioning here can be aligned, obviously, and can be interoperable with the EOS interoperability framework. For example, the discussion about the authentication authorization infrastructure, how it should be interoperable and allow mutual interconnection, and obviously how to integrate these functionalities, these enablers that we are generating as part, can be offered as a service, so that it can be part of any other EOS infrastructure that is that could be provided in the future. And that's all from my side. Thanks.
That is good. Excellent. Thank you very much, Antonio. A lot of information in a very short time. And Vila, set you the challenge.
No? Here. Okay, good evening, everyone. My name is not Alvaro Lopez Garcia. My name is Ville Tenhonen and so on. Alvaro, he couldn't make today this session, so I'm a substitute player here. But slides are made by Alvaro. Okay. About Siesta in a nutshell. Okay, it's one of these three EOSC 0106 projects. Budget 5 million. Started beginning of this year, January, and ending after 3 years. 12 partners, and all of them are not technical ones, and so on. This project is coordinated by Alvaro and by CICIC from Spain. Yeah, here objectives of the project. Its idea is to deliver trusted cloud-based environments for analysis of sensitive data built in reproducible way, and set of services to ease secure sharing through the state-of-art anonymization techniques. So there is a number of components which support fair management and secure anonymization, best practices, and extend this service offer of the EOSC portal or EOSC nodes in the future. Concept, here is different kind of access methods and based on the data sensitivity and different kind of levels of the sensitivity. There is a next slide about that. Well, there is also internal repositories and software components and libraries for these environments, and user-provided predefined software components that have been endorsed and approved, so that user can use their own information and their own components here. Assisted anonymization tools and so on, different kind of things. But this is one thing which is, in my opinion, is very essential for this trusted research environment, and it means that there is a different kind of sensitivity if we are discussing about data. There is a fully open, or there is a very high risk data. And then there is a different kind of levels of risk what we have to take into consideration when we are building some theories. And they means that there is some different kind of measures and implications when we have some risk. Meaning that we have to make those risk assessments for the data and other components of the theory. In this Siesta project, focuses on categories from 2 to 5. So there is a different kind of levels which is not so on focus in this project. This means this data sensitiveness means that there is a different tiers, and it means that data sensitivity definition is not static, and there is a different access models what we have to implement here also. And Siesta is exploring also these things, and so. Siesta implementation, there is a few cases: epidemiology, medical imaging, energy, text anonymization, and demography things. So different kind of use cases from different sides of the sensitive data world. Roadmap, I go pretty fast this one because there is in Zenodo this information project has approximately has just started, but there is also first deliverables in Zenodo and published one. Well, same thing with high-level architecture. Already these high-level architecture descriptions based on the C4 models has been done already, and they are also delivered by via Zenodo, and these descriptions are there. Okay, C4 more description model starting from context and then goes to the containers and then so on, and then there is a code, and it's this kind of onion model that first defining that where we are and then go to the deeper, and so here is architecture descriptions for all these major components like computing and sensitive data storages and so. Okay, in this project there is also exploring collaboration with different projects from EOSC ecosystem. Of course, this EOSC Entrust and Titan, they are clearly project which Siesta would like to collaborate. And then AI for EOSC, EOSC Grace, and so on. There is a lot of project which is connecting with this one. Okay, thank you for your attention. And so.
Excellent. I had to stop my timer. Thank you, Ville. That was absolutely perfect. Right. Thank you very much, everyone. So that was our presentations. I hope you've been thinking of your questions. I'm now going to introduce a few more faces. So Jonathan Tedds from Elixir, our scientific computing program manager, is going to take over and chair the panel discussion. I'm going to bring back people you've met, Heidi, Ville, Antonio, and introduce. Well, I'm going to say introduce a new face, but I can't believe in an EOSC meeting you haven't met Mark Dietrich before. But Mark Dietrich from the EGI will also join. So over to you, Jonathan.
Yes, please sit there. I'll stay here. Right, and can I invite everyone, the Slido, I believe there was an issue with the previous sessions where people were putting entries into Slido, but they weren't showing up to the moderators, but they are now. So if you recall the details for the Slido we presented earlier, I don't know if we can get those back on screen, but yeah, there they are. Thank you. So please do submit your questions online. So we haven't got long. We've got about just about half an hour, I believe. Let's just ask those panelists who haven't presented, which is just Mark, actually. So Mark, just quickly introduce yourself, please. Mark Dietrich from EGI.
Hi, I'm Mark Dietrich from EGI.
And your interest in this topic, please.
Oh, okay. Well, I'm very interested. I have two points of interest. One hat I wear is a data space hat. I've been working in the data space world for several years, and in the data space world, it's more closed than open, the data. So the premise for a data space is that it's going to support data sovereignty, which means that the data rights holder has the ability to control who sees, processes, et cetera, any particular piece of data. So how does that get done? So a lot of stuff has been built in the data space environment, but I'm not terribly convinced that it works. So I think the work that's being done in the health environment, or sort of prompted by, motivated by the 5 safes, as it is extended itself is a very useful model for how to do that. So save people, project settings, outputs, data. That was the thing I forgot. So that's quite useful. So wearing that hat, I actually participated last week in a seminar on the Common Data Interoperability Framework, CDIF, that's been advanced by World Fair at Dagstuhl, and sat in on a session called on data access. And we actually worked out the use of, on a preliminary basis or sort of a skeleton basis, a business process. Yes, it uses all the XACML boxes, but the fact is we talked very specifically about the real business process in terms of how to use different pieces of ODRL to actually express the policies, evaluate the policies, decide what to do with it. And the interesting thing that came out of it is that it's not just about the data, it's about the people. We need to identify the people and their attributes. It's about the settings. So the physical infrastructure that we're moving stuff around to has got to be well described. And within our community, we do a terrible job of that. We need to do a much better job of that. And the people, for example, in Gaia X are doing they've really thought hard about this for multiple years in terms of how to express the security attributes of an infrastructure. What is the endpoint? What is the stack? What's at the very bottom? What's at the very top? So I think that's very important for some of this discussion. Just in general, looking at how to practically implement this, the EU node, the EOSC EU node, doesn't have any of this. There is nothing in there to manage access to anything but open data. So if we start talking about, and we need to start talking about how to access sensitive data, and it doesn't have to be just health data, there's loads of other categories of sensitive data, then EOSC needs to build this in from the bottom up. It's not something we can paste on. I can talk about it more, but I'll shut up.
No, that's really good. Thank you. So you now have heard from all of the speakers on the panel and have some idea which aspect of the spectrum they're coming from. That could be misinterpreted. Yeah. However, you can see already there's questions coming in on Slido, so I can make a start on that already. We do have roving mics in the room as well, so if people just want to raise their hand, they can do also. But I'll start off with the most popular question so far, which is basically to quickly, please, go to each project and ask them to explain how their project connects to others. Now, some of you made small, brief references to that in your slides, but if you could try and help the audience just say how you think your project fits in alongside this other group of projects, so to help them get a better idea of what's happening in each project. So I'll start with Heidi.
Oh, thank you. That's a really good and important question, and I don't know if I have a good answer to that. I think it's evident that we have to work more closely together in the future. But I think the EOSC Trust is kind of at a little bit higher level of abstraction. Maybe we don't develop any specific technical solutions. The blueprints, it's a reference architecture. I think I was thinking when I was listening to the presentations that we should include your projects in the driver and provider discussions and forums. Both of the projects had use cases, I think, if I remember correctly. So yeah, I think there's work to be done. I think we can definitely find a place in this puzzle for each of the projects and not duplicate efforts. But I think closer collaboration and communication is in order.
Thank you, Heidi. Maybe Antonio next, and then we'll come to Veal.
Yeah, I mean, for me, it's difficult to say what it's easy to say what we are doing. I was in some sense, no? So basically, I would say if we want to say something about Titan is mostly, as I already said, is focused on the definition of these enablers. And what enablers is a collection of tools, basically, in some sense, that will facilitate the process of data sharing or the process of the processing of the data, in that sense, node in that sense, taking into account, as I already mentioned, certain kind of capability that are being provided by the node. So basically, and obviously we are demonstrating it with the use of some of the use case, basically. But our main focus, I would say, is on how to facilitate that this orchestration process should be carried out in that sense, between who are offering and who are consuming this data, I would say, in some sense. Maybe what we are less focused, I would say, is in the semantic aspect. We were just discussing with some of the colleagues, although we have a semantic interoperability as one of the issues to be taken into account, up to now, I will say, we have less put attention on that part, except on the issue on how to describe the capability of the node. And this is something that I connect very well with what Mark was mentioned, in the sense that we are not only aware of the data, of the description of the data, basically, but also the description of the capabilities of the nodes that are being part of the ecosystem, in some sense. And that will imply, in some case, users and processing capability. But I was saying that we are, up to now, we haven't focused too much on that aspect, I was saying.
Thank you. By way of moving to Veal in a second, can you just quickly comment on, there is some clear overlap in terms of, for example, tools around anonymization between your two projects. Yeah. Is there anything you'd like to say before Veal?
Yeah, because I already said it. I mean, personally, I think we already just comment that a couple of times also with Peter, I mean, in previous meeting that we already have. I think that there are some certain similarities, I would say, in some sense. But but I think we are more focused on certain technologies that we will use, I would say, specifically for the privacy preserving aspect and the confidential computing. Yeah. And while others are more focused on other kind of techniques that I think are complementary. So basically, I think the good thing will be to at least with the 3 projects at the end, being able to generate a collection of not common, but set of enablers that we can share between us and also offer it to the rest of the community.
Right. Yep. Sounds good, Veal. Any comments you'd like to make?
Yeah, of course, I'm a little bit in the position that, okay, I can promise almost everything, but it's not a good idea. I can see that, okay, this kind of collaboration, because these 3 projects are different. And the Siesta is a pretty practical one, and creating some kind of how can I say, demonstrations that how these kind of theories should work and so on, and how they are adding value for EOSC and so on. Then there is this kind of overlapping things in architecture descriptions and so on. So if these projects can collaborate in the area of those blueprints and how to tackle these technical issues and how to make those technical components interoperable and so on, that would benefit for all the projects.
If I can super quickly add, because it's almost too evident, I forgot to mention that we of course in EOSC Green Trust we have the providers. We have a big number of actors who are already either providing or developing TREs. So we bring this community aspect also to the table and organize the landscape of actors and create the network. So I think that's something that we provide that the other projects don't. But I think the 3 of us, we form a nice kind of whole.
Yeah.
Very shortly. In my general experience, if this kind of project could collaborate in the area of semantic interoperability, it would be helpful for everyone.
Mm-hmm. Thank you. Okay, well, let's move to another question. Don't see any hands at the moment, but we have plenty of questions in Slido. So let's look, I think we'll come back to how we look at results in a second, but perhaps if we move to the question, perhaps come to Mark first. What will a simple user or researcher need to do, in your vision, to access the services that we're building here?
Well, I'm not building any services, but that's one of the issues that we addressed, which was, if you look at the 5 safes and how that works, you have to know who your user is. You need to be able to understand their qualifications, why they have a reason to access the sensitive data that's being requested. Fundamentally, what's going to happen is, back to first principles, there's going to be a project proposal by a bunch of people who are going to say, I want to access your sensitive data to do some kind of research project. And they're going to have to say, well, we need to process your data in the following ways. We need to connect it with other data. We need to deal with the semantic interoperability questions of fiddling around with different data formats and trying to put them together so that they can be integrated in some way. So all that's got to be laid out up front. So one valuable thing is how we even describe that in something other than a 30-page PDF. How do we sort of in a machine actionable way identify who the safe people are, what qualifications they have, what projects are they involved in that gives them a bona fide reason to access the data, what training have they received, certified, have they completed training in the use of personal data? I mean, this is just the people piece of it. So I think all that sort of things can potentially be, I won't say automated, but we can go a long way to use the digital information that we have to present that information so that simple user can access this service. That in turn means that there's a defined entry point for the services. You can reach out to Siesta. Okay, spin up an instance of this for me. I want it to do so-and-so. So it's not just about the inside. It's like this black box thing that make a new one for me. I want it to do this. Here's my project proposal. Here are the people. Here are the data, et cetera. So that's my vision there. I don't know whether that's reasonable.
Yeah. So Heidi and then anyone else on the panel. I won't go to each of you for every single question, but Heidi, if you've got.
So that's a really good answer, and that's like how it should work, and it actually like works. One of the challenges currently is that the many of the providers we have in the EOSC Trust, and I think like just the TRE providers, they operate in the national context, they operate in the national funding under national legislation. So one question for that would be that you have to be affiliated with the right organization and in the right country, depending on what you want to do and which kind of data you want to use. And so that's one of the challenges for this federation, if there's going to be one. But to somehow allow users to access TREs from other countries than their own and access data also. So that's not a technical challenge so much, but a regulatory and policy and funding challenge as well.
Yeah, no, I mean, I was just thinking what you were saying. I mean, I think it's not only regulatory. I mean, in principle, I mean, I think it was important, as already was mentioned also by Mark, is to define a way to clarify what is the attributes that you need to present when you are wanting to access to a resource. And resource, again, could be anything. Could be a data, could be a computing resource, etc. So at the end, we need to have an infrastructure that allows us to say, okay, who am I, as you mentioned? What are the credentials and how can I demonstrate that I'm able to access to your data for what? And based on this, I can provide it to you, and then you are able to validate them, check it, and based on this, you can decide if you are going to provide it to me, yes or no, or in which conditions. I was saying some sense. Obviously, that could be also related to some kind of regulatory aspect in the sense that cross-border issues, as was mentioned previously, obviously the restriction that you can have depending on the country will be different and so on. But at the end, I think that the clear piece for me is the authentication authorization infrastructure that needs to be enriched from what already is being provided on the EOS infrastructure, so that really we should be able to have flexible on defining what are the policies, what are the attributes that are required, what are the conditions that you need to use in order to access data, all these aspects that at the end is something that already exists. I mean, we are not reinventing the wheel. This is something that in the security framework already exists. It's just how to put them in place, as you mentioned, with also some kind of data description and so on, no? Semantic model, whatever you like to call it in some way. No? But for me, this is the clear piece, basically, because the technology exists. It's just a matter of integrating them in a way, in a transparent way to the end user. No, that was one of the questions coming also. How a research will be able to do that? No, how will it be accessed? And I think that the work that EduGain, I would say, has done within the last 20, 25 years, I don't know if Alicia is here, and she knows that we have been working many years about that. I think it's a good framework, but need to be enriched. It is not enough for what already is being requested on the scenario of these open spaces that we are talking about.
Yeah, I mean, just quickly to comment from an Elixir perspective as well, and working with the life science research infrastructure partners, we've been part of this more than 10 years now journey building this common AAI framework in EOSC. And so I think there's a set of services that have evolved there that include attributes, information, and so on. But then it comes now, it's perhaps important for this family of projects to really test and feedback what does it mean to implement those services in these kind of use cases, and that raises another set of questions which we all need to work through. And a quick comment from Veal, and then I'll move to the next.
I agree about this, that we have all this technology what we need for these theories, and we have regulations, and we have rules, and we have these kind of things. And now I come back a little bit back to the siesta concept, where is those different risk levels for the data. It means that there is also different requirements for access. So if you have a low risk data, you do not have to have complicated accreditation process where you have to explain why you have to get this data set and so on and so. So this is the place where these risk levels comes visible.
I had a feeling that your list of categories of data might raise some questions, because we can all debate those. Let me just double check where we are. Does anyone have a question in the room while I just check which questions are now most popular of all? Okay. Oh yeah, please, let's have one in the room. Thank you, Peter.
When we are talking about data analysis in these trusted research environments, we also at some point need to look at code. And some of you mentioned in passing that trusted code repositories now may get clearance. But these are all living document objects and things, and people have ideas. People may make mistake. What checks and balances can you foresee how to monitor, control, in the worst case, sanction misbehavior, being it on purpose or for lack of knowledge or changes in technology, whatnot? What's your attitude to that aspect?
That's a great question. Who wants to start on that one? I mean, this is something that is being examined in one of the work packages of EOSC Trust, but I invite panel members to comment further.
I can.
Okay, yeah, Heidi maybe first, and then we'll come to the others.
Okay, well, yeah, I'm quite scared to address this question because I'm not a technical expert, but in the Interest project, there are roughly two types of providers. Of course, they can be grouped in several ways, but one way of grouping them is the ones that are both data processors and controllers, and the ones that are just data processors. So I think this question is a little bit different depending on which type of provider we are talking about. So the ones that are just processors, for example, my organization, CSC, that's our kind of way of providing services. We provided the services, the secure environment, and we don't really have access into the virtual machine when the researchers are working on their stuff there. So that's why we, in some use cases, have to put some limitations in what can be taken into the environment, because we have no way of checking the code. We can't have expertise on, and we can't scale up our activities so that we could check every piece of code that goes in. Maybe the situation is a little bit different for the organizations, for the providers who are also the data controllers, who have more kind of control over the whole process.
Yeah. Any other comments on the panel on that question?
Yes, this is actually a very good question, this software question. I see that, here is some normal methods that, development of the software have to be done outside of the theories. But it means that then we have to have some testing data which is not sensitive at all. Okay, nowadays we can use synthetic data made by AI applications and so on for that purpose. And then there have to be process how to evaluate that there is no catastrophic mistakes and so on. In software there is also always some mistakes. You can't avoid that, but you can control the risk again. And this means that, okay, what comes in and what comes out from the theory, this is essential in that part, but it's not easy task to handle or manage, but it's important. But.
Yeah. Okay, Mark.
So the control, the ultimate control for the most extreme, most sensitive data is going to be your control on the outputs. So it doesn't matter what software you used. It's a matter of what somebody looks at the output and says, did something happen? Did we release or disclose information that should not have been disclosed? And that'll be done with a combination of automated tools and some eyeballs. So now if you have a TRE that doesn't have this, that isn't applying a disclosure control mechanism, yes, then you need to rely on what information you know about the system, the infrastructure, the software that's being used. The trusted repository would be a controlled environment within that infrastructure. In other words, it's not just any old GitHub download. It's going to be something that was vetted in the way that you guys described. And there again, we have you cannot in computer science prove that there won't be a leak or that there won't be a side channel attack. So it to some extent becomes a risk that the data rights holder or controller is going to have to accept or not. So that gets decided up front. So those are your choices, I think.
Yeah. I mean, just to complement that, I think, at the end, actually there's certain work already. We are, for example, involved in some discussion with ENISA about how to create a certification of the AI algorithms. In that sense. So how to, in the same way that will be certification of security components and so on, the main idea is how to get a certain trustworthy on the execution of certain machine learning algorithms based on certain kind of tests and this kind of stuff. But at the end, either if that happens, all the process will be based on the trust. So in your ecosystem, you will need to have, information about who is providing this kind of algorithm, what is the trust that you have on that algorithm, or the provider of that algorithm, and maybe the certification will be something that will help you to get more insight about the trust that you can have on it. But at the end, it will be all based on the trust model. So you can have inside the governance model, maybe you can have a trust component that is in charge of checking, basically, as we already mentioned, what has been the execution, if there have been any kind of identification of a misbehavior because of a third party that already have validated and so on. But at the end, there will be the only option that will be available there, because at the end, there's no other way that we can have completely certainty about the behavior of the system in some sense. But I think that the work that now is being carried out by ENISA trying to identify how to do this certification, I think at least will increase the trust, I would say, on the solution that will be available in the future in some sense.
Yeah, okay. Can we send a microphone to a questioner at the back? Just quickly, before we come to that question, in case people aren't aware, there is a current InfoEOS project called EVerse. They're probably mentioning it next door, which is specifically developing, improving upon best practices in research software. It obviously doesn't directly address most of the points we're considering here because it's how things are executed and so on. I suspect the answer there to the question is more about there will be considerable limitations on how much people can on the fly adapt software that if it's being used in these kind of scenarios. But absolutely take the point that in reality that's how people develop software and they're constantly tweaking and so on. Question at the back.
Yeah, thank you. That's here Witold from the German Aerospace Center. And we have a lot to do with really restricted data, hovering between intellectual property and governmental classified data. And what I'm hearing here a lot is talking about trust, and that in the end, the owners of the data have to decide, or that it takes a pair of eyeballs to decide whether something is applicable or not, or the software in the repository has to be vetted one way or another. I'm sorry, but this is what we currently have, and this is why there's no interaction whatsoever happening, because everybody is thinking that nobody else besides them is able to assess the damage that might happen, and so everybody goes into Fort Knox mode. If I don't share anything, I'm not doing any errors. So, I mean, there are already technologies or approaches, for example, a software bill of materials, where we want to have a traceable and a reproducible way to show what happened with the software. And my question would be, how much are all these projects really looking into the technological implementation of those policies, and not just falling back on in the end, the data owners have to decide it their own?
Okay. Who wants to make a start on that, on the panel? Heidi, were you going to go first?
Sorry, could you
repeat the question?
Yeah, which policies?
In the end, what's important is who is responsible for something, and how do we want to establish a policy that there is a process to decide, I did everything along a process and I'm not the guilty party if anything goes wrong, because at the moment it doesn't seem so at all.
Yeah.
I just wanted to add, because my question is exactly about the same. It's partially a technical question, but with a strong focus on the legal solutions. Who is to blame, and it should be, I don't know, the nationals, the sector-wide, or the European-wide. Have you done like some work on it?
Well, this is now me not representing the project necessarily or my employer, but others can maybe to address the technical part. I see this as a kind of a risk appetite issue, and I think the data controllers have to be the ones who decide on that. And I don't see personally any other way. Maybe it's just my kind of lack of imagination, but there needs to be more readiness to take even very kind of limited risks. We tend to, in many organizations, we let the lawyers make the decisions when they should be the ones that advise, and then the leadership makes the final decision on the risk appetite. But yeah, I don't think there's any silver bullet for that. As long as we aim for like zero risk, then this is the reality we're living.
This nicely overlaps with a couple of the questions on that aspect in Slido as well. Yes, we're into the last 3 minutes or so, so very quick, any other points from the panel?
Yes, I come back again, these risk levels, and they defined in some organizations who is responsible for which actions. If there is a top secret data, then there is a legislation in different countries, and then there is a consequences, and there is a number of different kind of requirements for security measures. But if you have almost public data, then the levels are different. But this is it's a legal issue and decision-making issue and process issue. Yeah.
But maybe these tiers could at least provide, if we had like a common understanding of these tiers of sensitivity, that might bring some help to
Good
the
idea.
situation.
Okay, and probably the last comment from Antonio.
I would say that maybe not from the legal aspect, but maybe in our case at least, I mean, as a technique that we are trying to also working on is to provide attestation of all the actions that we are executing. So at the end, if you are processing, you are able to provide traceability of what had been done, what had been the request, and what you already have done. And based on this, try to have a way to check, as you said, if there had been inconsistency, call it in that way, between what was request and what was executed sometime. How to use it? I mean, up to now, we are not already there, but basically the technology that we are facing is the use of data station techniques, and that's why we're using the secure elements in order to provide trust also on that data station.
Okay, that's great. Can we thank all of our speakers and panel members and Peter for chairing for an excellent session.